In this video we'll learn to expand two sets of brackets. So if I have x plus 3 times x plus 4, what do I do in this case? What does this mean? I want you to imagine a rectangle. So we've got one side of it which is equal to x plus 3. So let's just suppose x ends here. This is how long x is. We don't know how many centimeters, so that's why it's x, an unknown value. And we've got plus 3, so 3 centimeters. There we have 1, 2, 3. So that's one of the dimensions. The other dimension is x, so same length as this x, plus 4, so 4 centimeters. 1, 2, 3, 4 of them. So what is the area of this rectangle? Let's just break it down. We've got this area here, which has dimensions of x by x, and x times x, we know that that is equal to x squared, and that is x times x. So we've got one term which is x squared. Now this one here was equal to 3, and this was equal to 4, so 4 centimeters. Now, looking at this area covered by x and 3, so we do 3 times x, so this is 3x. So we have so far covered this area here, and that was equal to x squared. Now looking at this area here, which has a dimension of 4 and x. So we work this out by going 4 lots of x, 4 times x, and that gives us 4x. So that's another area covered, and that is equal to x times 4. So we've multiplied this x here by both of the terms within the other bracket. Now let's have a look. We've got this area which has dimensions of 3 centimeters and x, so 3 lots of x, and we write that as 3x. Where is that here? That is 3 times x. What is left? There is this area here which has dimensions of 3 and 4 centimeters. So 3 times 4 gives us 12, and as you can see, there are 12 squares in here. So we're going to do plus 12. And where is that coming from? 3 times 4. So what have we done if we just recap? We took the first term within the bracket and we multiplied it by each of the terms within the second bracket. So x times x, which gave us x squared, and then x times 4, which gave us 4x. And then we moved on to the second term, the 3, positive 3. So that is 3 times x, which gave us 3x, and 3 times 4, which gave us 12. And you can see the visual representation of that in here. So it's like working out the area of a rectangle which has 2 dimensions. One of them is x at 3, x plus 3, and the other one is x plus 4. And we can collect the like terms here. So that makes x squared plus 7x plus 12. Let's try another one. So x plus 5 times x plus 6. So taking the first term within the first set of brackets and multiplying it by x. So x times x gives us x squared. Then x times 6, positive 6. So that gives us 6x. And now looking at the next term, 5 times x, which gives us 5x, and 5 times 6, which is 30. So collecting the like terms, we get here 11x. So x squared plus 11x plus 30. Looking at a few more examples. So we'll take 5 first and multiply it by x, which gives us 5x, and then 5 times 8, which is 40. Now looking at the next term, x times x gives us x squared, and x times 8 gives us 8x. Collecting the like terms, we put x squared first, plus the x's, so 5x and 8x gives us 13x plus 40 in this order. We call this a quadratic expression. Now looking at the next example, we're going to take x and multiply it by x, so that gives us x squared, and then x times negative 4, so that is minus 4x, and we've got 3, positive 3 times x, that gives us 3x, and then plus 3 times negative 4, or positive 3 times negative 4, that gives us negative 12. So we go x squared minus 4x plus 3x, that gives us minus x, or minus 1x. And that's the final version of the quadratic expression we are after. Now looking at this, we've got n's instead of x's, which is absolutely fine as well. You could have any letter. So we'll start with n. So n times n gives us n squared. N times negative 11 will be negative 11n. Looking at negative 9 times n makes minus 9n, and we've got negative 9 times negative 11, which is going to be positive 99. So we have n squared. Collecting the like terms here, we go minus 20n plus 99. We now have a few more examples. So negative x times x is going to give us negative x squared. Negative x times negative 8 is going to give us positive 8x. Now looking at the next term, we've got positive 3 here, which we're going to multiply by x. So that's going to be positive 3x. And positive 3 times negative 8, that's going to give us negative 24. So collecting the like terms, we get negative x squared plus 8x plus 3x So that's plus 11x minus 24. Looking at this one, it has 2y, which could be 2x as well, 2n, 2m. Doesn't need to be just the x or the y. So we'll follow the same procedure. 2y times 3, that gives us 6y. Then 2y times negative 4y. Multiplying the coefficients in front of them, we get 2 times negative 4, which is negative 8. And then we've got y times y, which is y squared. Looking at the next term now, which is positive 5 times 3, that gives us positive 15. And positive 5 times negative 4y. So we do positive 5 times negative 4 first, which gives us negative 20. And then we put the y after. Now collecting the like terms, and we start with the y squared first, the x squared, whatever it might be. So negative 8y squared. Then looking at the y's, so we've got 6y, take away 20y. That leaves us with negative 14y. Then we've got plus 15 at the end. Looking at the final example here, we've got x plus 6 all squared. So that means x plus 6 times x plus 6. So we just go x times x to get x squared, x times positive 6, which is 6x. Now positive 6 times x again is positive 6x, and 6 times 6 gives us 36. Collecting the like terms, we get x squared plus 12x plus 36.